IcSoft MES has got a comprehensive quality module. Let us look at what this module contains. The first component of the quality module is purchase inspection or incoming inspection for the bought out items. The next is manufacturing inspection or work in process inspection. As each operation in manufacturing is completed, there is a step of inspection, including the inspection of the final finished product. Digital work instructions is a quality related feature which works as a preventive measure of the operators causing defects in the product by giving them digital work instructions at their workstation itself. And last but not the least is corrective and preventive actions. So here, once we have reported the inspection results and we have identified the root causes of those defects, the quality module of IcSoft doesn't stop there, but it supports capturing the corrective and preventive actions to be taken to eliminate those root causes, then tracks their progress, sees the impact, and then closes a particular action plan. We'll see each one of these in detail now. We'll start with purchase inspection, defining item composition. Many of the tests of purchased items are based on their composition, different chemical properties which the items may have. For example, we see here carbon, manganese, and then there is a range. What is the minimum value which is acceptable and what is the maximum value and what we aim at. So this is the definition which is created for each item, and so here we see the item name for which this definition has been created. So we can then capture the actual values during inspection, uh, actual values of this composition, and take an appropriate decision whether to accept the item or whether to reject the item. Like composition, we can also define item inspector, who is responsible for carrying out the inspection. So here we have defined the person who is responsible for carrying out the inspection. And this comes very handy when we have to specially perform some random tests and we want to assign those random tests to someone. So that person needs to know that he is carrying out a particular test for a particular item. And this is something which we can actually see on the next screen, where we can filter the quality tasks by inspector, and each inspector can then select his quality tasks and carry out the inspection and then report the results. Similar to item composition, we can also define mechanical properties of the items. So here we see, for example, tensile strength, elongation. And again, we have minimum, maximum, and aimed values, and this is the unit of measure. So the expected results for each of these mechanical properties are defined here, which are later captured during the inspection. Similar to mechanical properties, there could be some other properties. These properties are mainly visual in nature. For example, shape or rust or the ovality, scratches, and the presence or absence of those is reported as the inspection result, which is in the form of okay or not okay. So we can see that an item can be inspected for uh, various attributes in IcSoft quality module. How do we report the inspection results? So all the items which are pending for inspection appear at the bottom grid. So once the GRN has been made and the next step is quality inspection, we can see all those lines appearing here. And the top grid, right now, the inspection has not been carried out. That is why it is blank. Otherwise, wherever the inspection has been completed can be seen here. So this is the section for pending inspection and this is the section for completed inspection. So how do we report the results? Once we click on a line which is pending for inspection, this screen opens and it asks the user to enter various details. So the dark ones which we see, this is automatically picked up here, and inspected quantity, total accepted quantity, accepted as normal, accepted conditionally with some remarks. All these details are filled up by the user. Once the user completes those steps, we can see the completed results against various uh, properties of the item. So this is so first row is visual where it says free from uh, burrs or scratches, and it has been reported here whether it is okay, not okay, kind of a thing. Similarly, when there are dimensions where the min, max, and aim is given, the actual values are reported here. Then again, same thing is done for the mechanical uh, properties for these items. So entry is taking place here and the results are being seen over here. So that was about purchase inspection. Now we come to work in process inspection. Work in process inspection is divided in four sections: selection, measurements, other details, and images and attachments. These inspections are attached to different processes in manufacturing. So here we can see that the screen is for assembly stage 6 and we are capturing the dimensional tests here which appear here, and certain details like which department this particular process happens, who is responsible for carrying out the inspection, what type of inspection it is. So it's a measurement. So whether we are doing sampling or whether we are doing 100%. So this is 100% inspection criteria. All those details are defined on this screen. So essentially the details are name of the test, like whether it is dimensional or setting, etc., which we see over here, whose responsibility it is. So whether it is quality or production, which we see in this drop down, what type of test it is. So whether it is, here we have defined it as measurement, and then what is the criteria, 100%, or whether a batch is getting inspected, whether what is the quantity per batch. So this is when sampling happens, or quantity per lot. So all these details are defined for that particular test for the work in process inspection. Next step is the measurements. So here we define a base value which is expected for the measurement, and these are positive and negative tolerances. And then the what is the unit of measure of the tolerance, that is given here. And in case the unit of measure of the tolerance is different from the base value unit of measure, there is a conversion factor which is also given. So idea of this screen is to define various measurements with permissible tolerances along with their unit of measure, and if required, a conversion factor between the tolerances and the base value unit of measure. So these are the tolerances, and here is the conversion factor as applicable. So here we can see that for the measurement, the minimum and maximum values are uh, already defined. Inspection method is defined. And in addition to these definitions, we can also define the gauge details. So it's not only the tests which are defined, but also the instruments. In this case, gauges. So their details are also captured for each test. Then there are some other details. In addition to the measurements, there are some other details which are captured visually, and those other details can be defined on this screen. What other information we want to capture. So those additional details are defined here. So, uh, for example, we may ask the operator to follow a checklist and report certain activities or report certain observations. So all those details are captured here. It is also possible to attach an image. So visually how the product should look like, how the item should look like, and an attachment of, so it could be a text document, it could be a checklist, it could be a standard operating procedure. So these are attached to the tests uh, for the inspector to refer to while carrying out the inspection. So images and technical documents like drawings, etc., can be attached. So how is the inspection then carried out? So once the production quantity is reported against any process or any operation, this screen will get activated and it turns green, as we can see it here. The user starts entering various values, the inspection results in this column. Okay. Then the completed entries would look something like this. All the inspection results have been uh, reported here. Depending on what was defined. So earlier we saw the definitions for various tests. Here the outcomes or the actual values, the observations against each of those tests are getting reported. Having completed all these inspections, it is possible to see the results of all WIP inspections for a given period. So we select a from date and to date here, and we select a particular test. So here we are talking about the dimensional details. So at a glance, we can see how we have performed or how the item has performed against this test for a given period. So those observations can be seen in these columns. The next critical feature is digital work instructions. This particular feature increases the productivity of the operators manifold and specially comes very handy when we hire a new operator or we hire temporary workers who don't have much experience in carrying out that particular operations. So latest and up to date drawings and designs are made available at the workstation itself. The videos can be made available showing how that particular operation is to be performed, or we can define various checklists or the things which have to be checked or steps which have to be performed during the operation. So all these things can be defined for digital work instructions. And having defined that, when it comes to carrying out a particular operation, the operator name is filled and we load the work order to start the work. As soon as we load the work order to start the work, the list of work instruction to be followed at this stage for this particular process appears here on the left hand side, which the operator keeps on checking. So this is a checklist, and once all the actions have been performed, he clicks on this image which shows completion of the process along with a date and timestamp. So this ensures that the exact sequence of steps in performing a particular operation are carried out by the operator, leaving little room for human error or human oversight. Rejection reasons. So in the quality module of IcSoft MES, we don't only record rejections, but we also record the reasons for each of the rejection. The reason on account of which the rejection took place. And these reasons are not something which are captured in text. So there are user defined reason codes based on their uh, experience, and that reason code is so these are defined here, different types of rejections. And during reporting the inspection results, if rejection is taking place, the rejection quantity is reported, no doubt, but the rejection reasons are also recorded, and which are very, very important for carrying out the root cause analysis subsequently. So, common rejection reasons which the quality department knows from experience, these are defined here, and during each rejection reporting, these uh, codes are captured. So here actually the rejection entry is taking place. What is the OK quantity? What is the rejected quantity? That is something which is reported over here. And here are those reasons. Okay. Why a particular rejection took place. So those reasons are recorded. The moment we reject a quantity, the screen pops up and asks us to report the reason as well. So here we can see the rejections stage wise. So here you see different stages. So this is yet to be completed. So this is something, and here we can see all the stages which have been, for which rejections have been reported. This also helps us in analyzing the processes where maximum number of rejections are taking place, and again take some action, uh, maybe on that machine or process parameters or tools being used. So subsequent to the root cause analysis, uh, the rejections can be brought down by taking necessary steps at that particular stage. So just like rejection, IcSoft quality module also handles rework. So in many cases, it's not just an acceptance or rejection. Many a times the item has a defect, but it has the potential to uh, get rectified. We can salvage that. So in such cases, we can report rework. So this rework selection, once it is selected over here, it initiates a process of rework where the operator performs to all the details of which process, for which process the rework is taking place, which department, the operator who is performing the rework, which shift, when did it start, when did it end, on which work order, which was the route, which batch, all these details are captured. And again, just like we saw the rejections, we can also see the rework quantity stage wise. So very important insights can be drawn by analyzing the rejections as well as the rework stage wise, so that we can pinpoint the sources and then take necessary action to minimize those rejections. So for a given period, if we take a filter and we want to see what was the inspected quantity, what was the rejected quantity, along with reasons, we can see it at one glance also by selecting the appropriate date ranges. An interesting report of IcSoft quality module is the Pareto analysis, or 80-20 analysis as we commonly call it. So once we have captured the rejection reasons, this report shows the uh, quantity of or the occurrences of rejections according to each of the reasons, and then a Pareto analysis of that is carried out, which tells us where to focus on if we want the maximum uh, impact. So in this case, we can see that dent at fixed pitch is the defect that if we take care of that, majority of our quality problems, not all, but majority of our quality problems for this particular part will get resolved. Another view of this Pareto is a pie chart. So here we can see this dent at fixed pitch. So this part of the pie, which is the biggest pie, and then the next one is missing notch, so on and so forth. So what do we do once we know that, for example, dent at fixed pitch or missing notch? These are my top reasons of defects. So we want to focus on those. And once we decide to focus on those, what do? We trigger a corrective action, preventive action, or kappa. How does kappa work in IcSoft? We capture reason code wise defects. We do like we did here. Okay. And we said, for example, that dent at fixed pitch or missing notch is something which we now need to take care of. So next step is we do a root cause analysis. Why these defects are taking place. And we may identify something to do with the machine, something to do with the tools, something to do with the way operator is performing certain operations. And we arrive at the root cause. Once the root cause is identified, we plan certain actions. So we don't only stop at the analysis, we plan the actions, what corrective actions we can take to fix what has already, the defects which have already been uh, injected, and what preventive actions we can take in order to avoid those defects in future. Again, we don't stop at the planning stage itself. When we actually execute those actions, for example, it could be, refurbishing certain tool, or it could be uh, calibrating certain equipments. So whatever is the corrective action, we report those actions. So whatever we planned, when we took those actions, and again, we don't stop at taking those actions. We go back and we check the results. So we go back and we create another Pareto and we see whether really these defects are coming down or not. So nothing is left to chance or wishful thinking. The entire process is planned meticulously, executed religiously, and tracked at a granular level. So quality is not left to chance with the quality module of IcSoft MES. It is ensured. If you want to know more details of these features which we just saw, please call us or contact us for a demo at sales@itspl.com. Thank you.